today is our last class for Material Science for Chemical Engineer, CHEN 1311 for semester 2, 2001-2022. So today we have what we call the group of the student will present about the 3D printing to their colleague. So let me introduce first their what I call their members. So on my right there are one Ain, and also we have Farah here, we have Rauda, we have Arina, Amirul, and also Aisa. So without further ado, I will pass the floor to them.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello and good morning everyone. I'm Aisa and I with my other members will introduce to all of you the unique of the 3D printing technology. So, do you guys ever wonder how these products are made from? This specific and complex design, and how this can be beneficial to our life nowadays. So, actually, 3D printing is started in 1980s and was first was discovered in Japan. So, I will introduce to you guys what is 3D printing. 3D printing makes tangible objects from computer designs via additive manufacturing. So, the method involves fusing small layers of liquid or powdered metal, plastic, or cement. So, basically, 3D printing is a three-dimensional, which is a real object that be used in manufacturing process and to create a physical object from a digital design. So you can design in computer and make it real. So the process works by step by step, layer by layer. So you can use the powder material or a solid material or plastic metal cement, and then it fused together layers by layers and form until it reach the desired shape. So there is many types of material that can be used in 3D printing, such as ceramic, PLA, ABS, and resin. So basically all of these material can be found in laboratory. So in heavy manufacturing, so there is many other material that manufacturer can choose on their desired characteristic of their design. So the products that can be made through the technique of 3D printing are as varied as the materials that can be utilized to make them. So 3D printing is adaptable enough to enable manufacturers or the creators to choose the form, the surface, and characteristic of their products. So to top all of it, generally necessary in conventional methods of manufacture. So this is the best part. In addition, these items are capable of being produced to produce a variety of products, a variety of goods using 3D printing materials. So all of this will be explained further by other members. So there is three broad types of 3D printing technologies that commercially used in manufacturing industry. So the first one is sintering. Sintering creates high resolution products by heating material without melting. So the sintering thermoplastic powders used in sintering. So basically the printer will shoot laser, but the laser not melting the base. So the base we use is powder usually in sintering. So we not heat the material until it melt, but it just shoot the laser beam on the thermoplastic. This base is powder, so it will form a crust until it reach a shape that we desired. So the second type of 3D printing is melting. So melting method is used in 3D printing include power bed fusion. So it also use a powder, can use a powder, and also there is other method in melting is electron beam. They shoot electron beam like in the animation there, and direct energy deposition. So they are use lasers, beams, but the melting is you heated the material until it melt. So it will solidify in room temperature. So it's slightly different with the sintering. Sintering is not heat the material until the melting point. So melting is melt until it's reach melting point and will solidify in room temperature. So the next types of 3D printing is stereolithography. So stereolithography use photopolymerization, which is it involve light energy. So the technology use the right light source to make them to polymerize the material. So material generally we use polymer. So we have to use the correct light source to interact with the material in a selective manner to cure and solidify a cross section of the object, layers, the thin layers by layers. So I would like to pass the presentation to the next member, Sister Ain.
Thank you, Brother Aisa. So for my hi, I'm Ain. So my part, I will explain about software for 3D printing. For designing models, we use at least two software, which is Autodesk Fusion 360, Ultimaker Cura. To design a model, we can use Fusion software. You can get this software online for free if you are a student or educator. So you just can search this on Google and try download it. And Fusion 360 actually has a lot of feature, but today I will be explaining about 3D modeling only. So you can use this Fusion to create and edit your object for 3D printing. This is the view in the Fusion. As you can see there, we have create and modify choices. But I won't talk about this how to design, because it will take so much time. So I want you all to explore it by yourself. And you can also bring other models into this Fusion and make some modification, changing the scale, removing some parts, and more. And in Fusion, if you want to import files, such as to make a logo, you want to import file from Google, you can just import it like that, because in Fusion, you can only insert SVG and DXF file. So if you want to convert image, you need to change GPG first to XVG first, and then only then you can insert in Fusion. So as I said about the model template, you can search any template in this website, www.thingiverse.com. As you can see there, there's a can opener. You can just take this template from here and print it in there. Next software is Ultimaker Cura. This is for slicing and preparing for 3D printing. This software is free, don't worry. Okay, but first, what is slicing? Slicing means slicing your design into individual layer. Tak boleh. Okay. For slicing, actually it has video, but it doesn't work. So in Cura, huh? tukar. Okay, continue. After that, this software also can generate the toolpath in G-code files to toolpath for the 3D printing. And Cura has preview. Actually has video. It slicing it into the individual layer. For this pyramid, it actually has many layers. It has video. But it doesn't work. Okay, what's so special about Cura is it can connect straight to your 3D printer. You can also add a non-network printer because Cura has a list of all available 3D printer that exist. And the most important part in Cura is the setting before the printing, such as materials that we use, printing temperature, build plate temperature, printing speed, quality, and more. This setting will definitely affect your printing outcome. But Ultimaker Cura already has a recommended setting. So, but last and but not least, you can also edit the measurement in the Cura. So that's it for the software part. I will pass the floor to another presenter for demo for the 3D printer.
Okay, hi everyone. So this is the best part. I need one volunteer to do this demo. Who wants to volunteer first? It's not hard. It's not hard at all. Just, I need a volunteer. I'll guide you. If not, I'll pick a name. Come on guys, this is the best part. Shamimi, come. Please welcome. Okay, so now as you can see, this is what we call the filament just now. This filament can be determined in the Cura. So this filament, we're using PLA. So if you want to print something, you have to set the filament in Cura first. So that means you have to set it PLA. Otherwise, it will not be as the model as you want. So what we do first, because I want to change the filament. So what we do first, you can press the knob here. Okay, and then you can turn the knob until you see unload filament like this. Try turning other way around. Sorry. Okay, press unload filament. Yep, just press the knob. Okay, so. Okay, then you pull the filament. Pull it out. Just pull it. Alright. Okay, so it's out now. You may see. Thank you. I need another volunteer to fill in the filament. Who want? Saini, come. Thank you. So you may take the filament up there. This is PLA too. So we've already set the filament as PLA, so it's no problem. And then you just put it here. Okay, so now what we do, we are going to load the filament inside this. So now you can press the knob, press again. Okay, and then try turning the knob until you see auto load filament. Yeah, and then press it. Okay, now you take the filament, take it. Try press it again. Press the knob again. Okay, press again. Okay, then fill in here. Okay. Okay, you can see you can feel the filament will go in automatically. Okay, you can just. Okay, now it's already in. After this, we are going to print. So the shape that we are going to print today is a pyramid shape. It's just a small shape. So basically, the printing time will, it will take longer time if you print bigger objects. So like for today, we are going to print a small pyramid, so it will take around 11 minutes. All right, so you can see here, okay, after you load the filament, and then they will ask, is the color correct? So if not, sometimes there are some leftover filament inside of this thing. So if the color is not correct, you can just press no and it will load again. Okay, so is the color correct? Yes. Yeah, so you can press yes. Okay, thank you. So moving on to printing. Who want to volunteer to print? Come on, guys. It's not, yeah. Thank you. Okay, so now what we do is, you can just wait. Oh, I forgot to tell you. Before printing, it will preheat the nozzle because you know it will melt the filament, so it needs to be heated. So for this PLA, you can see the bed, the nozzle temp and bed temperature here. So you have to set according to the filament type because for let's say for this PLA we are using 215 degrees Celsius. So if you this nozzle temp is around 205 to 220. So let's say if you heat it more than 220, it will tend to burn. The filament will tend to burn and it will not come out as what you want, right? So same goes as the bed temperature. We need to heat it for the model to stick when you print. Okay, you can feel the bed. It's quite warm, 60 degrees Celsius. Okay, so now what you do is you press again, and then you turn until you see print from SD. All right, just print. Okay, and then you turn until you can see pyramid G code. No, bawah lagi. It's just pyramid. Yeah. All right. Okay. So now what is it is the nozzle now is heating. So you can see here it's 211. Okay, and then now the thing is doing leveling by itself automatically. Okay, this is just a short story. When we did this bed is actually we can take out, and then we didn't put it like as what it should be. So this is actually because it's automatically. So when you didn't put it correctly, your printing will not be correctly lah. Means it cannot print at all. It will appear here calibration is not correct. So what you do is you have to readjust the bed. Okay, so now it's just printing. So you can just wait until it's done. Okay, you may have a seat. So while waiting for the printing to be done, I will pass the presentation to Amirul to explain about the next presentation.
Hi guys, my name is Amirul. So now I'm going to talk about parameter that decides the success of your 3D printing. So basically that 5 parameters that you need to consider for you to have a successful 3D printing. So first of all is the part size. Most 3D printers work with a closed build platform because it will be doable to print several parts simultaneously. The smaller your objects, the more you can combine in one single build, saving operating expenses, material, and time. Also, that can also make the size of the parts to be printed easily. Like how large objects can be easily split up into sections, but that might require extensive assembly afterward, which conflicts with producing fast parts, integrating the functionality, and also reducing the number of components, as well as some of the 3D printing's main advantages. So every part of the size of a football surely has the potential to be produced in the cost-effective way by using a 3D printing. Next, the second one is part complexity. So for part complexity, as we all know, 3D printing is the freedom of design. A product with complex geometry will be harder to import, will be almost impossible, but it's still possible to be printed. Thus, it could also be costly to make the traditional techniques to produce that kind of 3D printing. So with the right approach to design and engineering, there simply is no other cost-effective technique to address design challenges, such as incorporating difficult undercards, integrating functionality, hence why complexity is free in the additive manufacturing. Next, the third one is project value. The total commercial value of the device or equipment is essentially something that you will need to take into consideration. 3D printing is a component that can add value to your product in terms of customization, functionality, time to market, etc., etc. But that's not the case because it's not adding the value, it's probably just adding the cost. So for price-sensitive consumer goods, these costs will be much harder to justify, especially for the high-end industrial solutions. And the third one is the series size. The quantity that makes 3D printing to be considerable production method is by differentiating it in every single project. Because what's clear is that there are no fixed costs like molds, which actually influence your parts price. You should know that the cost per part will always remain the same in 3D printing regardless of what the total quantity might be. A balanced volume or price ratio will also be highly depending on the other four parameters that I have mentioned and talked about, which is part size, part complexity, and project value for 1, 2, 3, 4, and purpose. For example, although the price per part does not decrease for bigger quantities, a large series still can be relatively cost-effective as you might save off on assembly. And the last one is purpose. So what is the purpose of your object? Does it have any function, or does it only need to be looking good? Or both, perhaps. Because nowadays, everything is possibly in terms of post-processing and finishing to enhance the quality of the surface quality of your 3D printing, like painting, smoothing, dyeing, coating, and metal plating. However, as with everything in life, the more you want, the more you will pay. And so yeah, that's it. Now I'm passing to my other group mate. Thank you.
Hi, my name is Farah, and I will present the 4 types of FDM. So, Cartesian 3D printers. This is the most common type of FDM 3D printer, just like Prusa right here. As you can see, it will represent the lateral, longitudinal, and position of a point, X, Y, and Z. The next is Delta 3D printer. Delta 3D printer are the second most popular type of FDM. They can be easily differentiated from a Cartesian 3D printers because of their tall appearance. The print head is connected to the 3 arms of the printer, and they all operate in a sync to print the layer of the object. As you can see here, instead of positioning the print head according to X, Y, Z and position, each of the 3 arms change its angle to position and the print head on the build platform according to the model. Next is Polar 3D printer. The position of a point is defined by only 2 numbers of an angle in 3D space and the separation distance from a predefined center. The build platform to a polar 3D printer can move left to right, back and forth, and can also rotate while the arm print head only move in the Z direction. As you can see, the plate here can move, and the print head only move in the Z direction. And lastly, SCARA 3D printer. SCARA 3D printer resemble the industrial robots arm and offer greater freedom and flexibility when printing. So it can print much larger object. And it moves in the most similar way to human hands. Next, I will pass back the floor to Rauda.
Okay, so hi everyone. For this part, I'm going to present the common types of filament that is used for 3D printing. So there are a lot of filaments that is used, but these 7 filaments are the most common type used in 3D printing. So the first one, PLA, stands for polylactic acid. So every filament has its own printing temperature and also bed temperature for the best result. So for PLA, this is just estimated value because the exact value you can find on the filament itself, right? So for PLA, the estimated 180 to 200 degrees Celsius. For bed temperature, the best temperature is 40 to 60 degrees Celsius. Okay, they also have printing speed. So this printing speed also can be adjusted from Cura. So actually for the printing speed, the faster the speed, the faster it will print lah. But it may cause some effect in the result. So means it will not print correctly lah. Alright. So the advantage of PLA, it's cheap, biodegradable in 50 days, but it is brittle. So it's more used in aesthetic purposes rather than something that is durable. Alright. So the next one is PETG, stands for polyethylene terephthalate glycol. So the estimated printing temperature is between 220 degrees Celsius until 270, and bed temperature 75 degrees Celsius to 90 degrees Celsius. For printing speed, the best printing speed is 40 to 100 millimeter per second. So the advantage for PETG is durable and easy to print, but it is susceptible to moisture, and also the surface can scratch easily. So for the next part, nylon. Nylon is also one of the best filament for 3D printing. So it has printing temperature 220 degrees Celsius to 275 degrees Celsius with bed temperature of 70 to 90 degrees Celsius, and the best printing speed is 40 to 80 millimeter per second. So the advantage of nylon is durable. It has high melting point so that it can sustain friction heat, and also has high impact resistance. But the disadvantage is nylon has hygroscopic property, which means it has the ability to absorb moisture from air. So a short exposure to humidity can affect its quality. So the next part, ABS, acrylonitrile butadiene styrene. It has, for the best printing temperature, 220 degrees Celsius to 250, with bed temperature 50 degrees Celsius to 75, and printing speed of 40 to 60 millimeter per second. So we move on to next material, which is TPE, thermoplastic elastomer. So for TPE, the best temperature is between 200 to 250 degrees Celsius, bed temperature of 50 to 75 degrees Celsius, and printing speed of 20 to 40 millimeter per second. For PC, polycarbonate, printing temperature of 260 degrees Celsius until 315 degrees Celsius, bed temperature of 80 to 120 degrees Celsius, and printing speed of 20 to 40 millimeter per second. So last but not least, PVA, polyvinyl alcohol, with a printing temperature of 190 to 215 degrees Celsius, bed temperature of 70 to 90 degrees Celsius, and printing speed of 40 to 80 millimeter per second. So that's it for my part, and I'll pass the presentation to Sister Arina for the last part of this presentation.
So, hi, Assalamualaikum. I'm Arina. So, we are already at the last part of our discussion, which is I'm going to explain about the advantages and the disadvantages of 3D printing. Okay, so the first one, it offers flexible and fast design. It allows for design and print for more complex design compared to the traditional manufacturing process. It can offer saving time in manufacturing process by creating STL files that we custom in Cura software, so it can ready to be printed. Next, it can minimizing waste that lead to environmentally friendly. The production only required the material needed for the part only, so there are no wastage. Next, the last one is it offers cost effective. This is because it reduces the cost on material, as it only use the material required for the part itself. Like I said just now, there are no wastage. If the 3D printing equipment is expensive to buy, so you can avoid that by sending your project to the any 3D printing service company that available. It also saves time because you don't need to be there for the entire time while the printing process, while printing. Okay. So next, I'm going to continue with the disadvantages of 3D printing. First one, limited material. Only selected plastic and metals are available at the available section. This is because not all metals or plastic can be temperature controlled enough to allow 3D printing. The next one is size limitation. It has small chambers, so it restricted the size of the part that need to be printed. Next, design inaccuracies. By using printers with low tolerance, so the final part may be slightly different from the original one. So it can further increase the time and the cost of production because we maybe need to restart the production again. Okay. Next is the copyright issue. 3D printing become popular and easy to access, so it have greater possibility for people to create fake products. Reduction in manufacturing jobs. It have potential reduction in human labor because most of the production process have been done by the printers. Last but not least, the post-processing. So even 3D printing, it allows for fast production of part. However, the speed of manufacture can be slow by the post-processing. The large parts require post-processing because most of the 3D printed part need some form of cleaning up. So the benefit of cleaning up is to remove support material from the build and to smooth the surface, so we can achieve the required finish. The amount of post-processing, it depends on the factors itself. It depends on the size of the parts and also the type of the 3D printing technology that we use at that time. Okay, so that's all from our discussion. So we're going to continue with our Q&A session.
Tukar slide.
Okay.
Alright, we're going to continue with the Q&A session. Firstly, I will ask one question, and is there any volunteers to answer the question? You can come in front. Alright. So the question is, based on all the information given, what is your opinion about how 3D printing can give impacts to the environment? So I will repeat the question. Based on all the information given, what is your opinion how 3D printing give impacts to the environment? If you want to, okay.
It gives impacts to the environment as it is minimizing waste and it is environmentally friendly.
What is your suggestion how to preserve our environment with all this technology, 3D printing? How can we preserve our environment? So, what is your opinion, your own answer? Can you suggest one?
My opinion, it can be recycled.
Recyclable materials?
Yeah.
Okay, thank you. Give an applause. All right. So, do you guys have any other question to ask us, or you want some to clear up some confusion so we can answering your confusion? Just one question. So, is there any other question to clear up some confusion or the things that you eager to know about printer, about the design, about the material? No? No question. All right. Yes, brother. Coming from.
Just a simple question. So basically, the materials that we use to do the printing, 3D printing, is usually use the polymer materials.
Yes, usually in lab, we have the many types of polymer. So, but there is other form of materials such as metal powder. We can use resin and ceramic that we learned in previous class, and the other type of thermoplastic. So basically, in the lab, we can find material based from thermoplastic because it involves a polymerization process. But in heavy industries, in manufacturing industry, usually they use the slide shows metal powder, cement, so to have a more high resolution of products, the high quality of products. So it depends on the products to what material that we can use. So in the lab, usually you can find a polymer, PLA. Okay.
Thank you.
All right, thank you for your question. All right, I think that's all from us. And I would like to invite all of you to experience yourself with this 3D printer, with what we have designed before. And yes, you may come to the in front and experience yourself. Enjoy.
So, it's already done. So one of you can take out the model from here. Just take. Just buka.
Okay, nah. Siapa nak pegang?
Yang tu dia tak jadi sebab expert ni. Nampak ni diorang buat
Ni tak jadi sebab dalam kura tu kena masuk nama printer yang betul. So kalau lain sikit je daripada nama printer yang ni, so dia akan jadi, dia tak jadilah design, dia akan separuh jalan je, halfway.
Yang ni pula tak jadi sebab salah design. So means design tu penting untuk printing. Salah design pun memang printing tak jadi.
So dekat kura tu kena set up betul-betul lah material apa guna. Yang ni boleh je download dekat website Thingiverse. So dia akan terus buka dalam Cura tu. So boleh direct print lah.
Ini guna sama ke filament yang sama?
Semua PLA. Ada yang selalunya kalau besar macam tu lebih boleh sampai 8 jam. Macam piramid tadi kecil ni saja baru 11 minit. So dalam kurang tu boleh resize lah ikut masa berapa lama kita nak
Ni
ni.
first kali design kita orang print guna printer. Guna printer ni. Ni first design kita orang print guna printer tu.
Cuti ke ni berapa jam?
3.
8.
Jadi lepas tu apa yang tak ada tebal sangat ke apa? Sebab
Okey.
dia design tu kompleks.
Tengok ni design ni. So kita tahu 3D printing layer by layer tapi dia bukan vertically axis tegak ke atas. So dia ada edge kan, ada ni. So dia dalam Cura tu boleh generate support supaya tak overhanging kat dekat ni. So dia takkan waktu print dia takkan jatuh. Actually ada support dia.
Tapi yang support yang tercabut.
Okay, support dia pun dia akan print sekali. So basically akan jadi macam ni lah supaya dia takkan jatuh. Waktu dia buat proses print tu lah layer by layer. Sebab overhanging ni memang kena generate support dia. Dalam Cura tu boleh auto, boleh custom. So dia akan tambah masa lah kalau you generate support. Dia akan tambah masa sebab dia akan print support di sini. Tapi tak apa. Sebenarnya kita boleh cabut je guna tangan, boleh guna pelayar. Dia akan dia akan print supaya senang untuk cabut lah. Kalau makin banyak you punya design tu banyak yang hanging macam bentuk L terbalik ke kan. Macam tu kan nak buat crane tu kan. Kan atas tu kan takkanlah dia nanti jatuh bawah kan. So you kena generate support lah supaya dia stand still.